Okay, I believe I'm now recording. Should have audio. Regina, wave at me if you can hear me. Okay, I see a hand waving there. Cool. Okay, I was going through and coming to a getting some solutions to Module 8, getting ready to grade them. I'm getting caught up on my grading now, so you should be starting to see me get things turned in or get things headed back to you. I'm working on that as quickly as I can. And I wanted to talk a little bit about Module 8. A couple of them were kind of tricky. I thought numbers 7 and 8 were a little bit tricky. So I'm going to pull up. Let's see. Let's look at number 7. Okay, I'm displaying number 7 on the screen now, if I can get it there. And it's asking us to write a select statement that returns the vendor names and cities, or excuse me, the name, city, and state that are located in a unique city and state. In other words, do not include vendors who share a city or state with any other vendor. Now, this would not be difficult if I were only asking you for the city and the state. That's pretty easy. But when I throw in the vendor name, and say that, gee, now you have to give me the vendor name, now it has to have a derived query in there. So tricky part of this one is getting the vendor name. If I put the vendor name in the query, then I would have to group by the vendor name. Let's look at it here. I'm going to write a select that just gives me the city-state pairs. So I have that up now. And I did put this out, by the way, as an announcement where we can, so you have this file available to you, or this text anyway. It's in the announcements. And I'm going to select just the city and the state. And I threw the count in here just for fun because I don't need it for anything, but I just want to see that it's showing me a count of 1 from vendors, grouped by vendor city, comma, vendor state. If I put the vendor name in here, then I have to group by the vendor name. Are you with me? And I'm going, so every time the vendor name changes, even if the city and state are the same, I'm going to have a new group. So if the ABC company is located in Frisco, Texas, and the XYZ company is located in Frisco, Texas, that's going to be 2 different groups. Okay. I just want the vendor city, vendor state that are unique, and I get that unique by having count star is equal to 1. I saw a couple that I was just glancing through at what people were doing. I saw a couple where they said where count vendor ID is equal to 1. And yes, that will do it. But I don't really care. Once I group it, I just want to see how many records I've got in that group. Okay. So if I were to run this query, and we'll execute and take a look at our output. Get me out of there. I see I have 38 rows. I have 38 rows. Now, you might play around a little bit with your data. If you want to watch them change and watch your output change, that's fine. If you want to add another city and state and see what happens, that's fine also. I will see it when I run it. I will run it against my data, and what you have in yours doesn't matter. I won't see that. Um, so I'm seeing the count is 1 on all of these, and that's what I wanted to see, is this column of ones in here. Everybody in there is 1, and I have 38 pairs of unique city and states. So I only have one person, vendor located in Gardenia, California. Now I can test this a little bit if I want to see it a little bit better. If I execute it without the having, so I'm just going to take that out of it, and I'm only going to highlight the select group by vendor city and vendor state. Now I'm going to get a completely different outcome. Now notice that I have 3 in Phoenix, Arizona. Goodness gracious, this author must be from Fresno, California. I happen to know that they're located in Fresno. The publisher is, and so on. 41 in San Francisco, no, 4 in San Francisco. Cheap pair of glasses today, and so on. But so I'm confident then that just this subquery is giving me the data that I want. Now the trick is, so I should have 38 rows. I'm going to have 38 rows in my output. So if I add the vendor name into the query, so I do this here, I add in the vendor name. Once I add the vendor name in there, now I have to group by the vendor name. Okay, I can't just group by one field. I either have to group by all of them or none of them. So once I throw that in there, now when I execute this, I'm trying to get the vendor name. Now notice that I have 122 rows. And for example, now I see Abbey Office Furnishings, Fresno, California, the first one. And we go down to the fourth one, I see ASC Signs, also in Fresno, California. Why are they coming up as different groups? Because the name has changed. So I can't have the name in the subquery. I can't do this in one query. So we'll scrap that one. Now back to the original. So the derived table is this one. And I say in the announcement, I'm going to name it D, if that's okay. Now, we're going to select V from vendors, name, D.city, D.state, and yeah, I know I don't have anything named city and state. It's vendor city, vendor state. Okay, leave something for you to figure out. From vendors as V, that's where I get the V. Inner join D, where the cities are equal and the states are equal, and then toss in the order by. And if your data are the same as mine, you'll get 38 rows. If they're not the same as mine, you won't get 38 rows. That's okay. Any questions on number 7? And if you have changed your data and you want to put it back like it was, just run your create ap.sql. That's what it's designed for. It puts your data back. Some of the dates will change. So each time you run it, it will update the dates to where you have, and when we're working on dates, we're going to have to run create ap.sql. Questions? I noticed the few that I have turned in. And I think, when was this due? Is this due? Today. Okay. So this means I will probably start grading Module 8 if I'm on track. I'll probably start grading it on Tuesday while I'm on the train. So if you turn in this weekend and you're fine, you're on track. I've only got 3 submissions for this class, but that's fine. Write a select returns 4 columns. I need to have vendor name. I need to have invoice number, invoice date, and invoice total. Well, what tables do I need to get those data? Vendor name, vendor table, vendors table, and the invoices table. So I'm going to have the vendors and the invoices table in there on an inner join. Okay. Return 1 row per vendor representing the vendor's invoice with the earliest date. Okay. So I should see all of the vendors that have invoices. My question is, how many vendors do I have that have invoices? Well, let's ask our database. What if I ran this query? Select vendor ID, invoice ID from vendors as v inner join invoices on the IDs being equal and order them by the vendor ID. I should see all of the vendors for whom I have invoices. So when I run this, I see that I have 119 rows, 113 rows. Crummy glasses again. So I have 113 unique vendor ID, invoice ID pairs. All I'm getting here is just the pairs. I haven't tried to get the dates yet. I was tempted to write this one this way. Select vendor name, invoice number, invoice date, invoice total from vendors, invoice inner join invoices where the invoice date is in. So this is the way I'm most comfortable going this way with a query. I like it when the when my subquery is in the where invoice date is in. And that's kind of the way I try to go with it. I'm thinking that way by default. Will this work? I'm not entirely sure why it doesn't, but I ran that other query. I want to know how many pairs I have. So how many, let's run this and see what I get out of it. I'm getting 57 rows. Now, what I'm thinking is that this is by vendor ID. I'm getting the minimum invoice. I'm getting a list of invoices that are minimum IDs, but I don't know which one it is. So I'm asking for the invoice date is in this. So everybody give me the vendor. Notice that this isn't grouped in any way. So where the invoice date is somebody's minimum invoice date. All the SB is in the set. And notice that I cannot run a correlated subquery down here, I don't think. Anyway, I was trying that. I was trying to go with I using this name out here. I tried it several ways, and I wasn't able to do it. And I finally decided that the approach to this, number 8, was I'm going to inner join with that. So where the vendor IDs are the same. So now this lets me, I'm interjoining on the vendor ID. I've selected the vendor ID and the minimum invoice date as, and I have to give this an alias, and I have to alias this guy. So now when I run him, let me go back. Now notice that Mallory Lithographing, invoice number 2058 has the date here. I'm getting 113 rows. Do I have the right interpretation of that problem? That problem, by the way, came from the text. Let's go back and read the problem once more and kind of work on this together. Returns 4 columns, 1 row representing the vendor's invoice with the earliest date. I don't believe I have it yet. I don't believe I have the vendor's invoice with the earliest date. Okay. And let's see if I can tickle this last one. Let's try this and see what I get. Write a select statement that returns 4 columns: vendor name, invoice number, invoice date, invoice, 1 row per vendor. And that, yeah, so that that approach to it that I was working on, this should give me how many vendors do I have that have invoices. I don't, if vendor ABC has 6 invoices, I don't want to see 6 rows. I want to see 1 row. Let's find out how many I've got. Okay, I should be seeing 33 rows in the output. With me there. A group by would. I'm playing fast. I'm just trying to get some information about it. How many rows am I expecting to see in this output? So by writing a quick little query like this, I can get an idea of how many vendors have at least 1 invoice. A group by would do the same thing. So let's run this one. Select vendor ID, the minimum invoice date. Let's run this subquery and see what it gives us back. Okay. Executing. And here I've got 34 rows. Why did I get 33 rows here? Oh, I know why, because I've been messing with the data up there. I think there is an invalid Yeah, there is one invalid date in there. I put that in there just to give us something to find when we were looking at the outer joins. So I'm expecting to see 33 rows where I have this in the invoices grouped by vendor ID. I believe I have one invalid vendor ID. So when I do the table join, that invalid vendor ID should just drop out. Excuse me. So I'll end up with 33. Go ahead. Uh, this is the way that I was working it. And so I'm really working this to come up with how I'm going to grade them. Select vendor name, invoice number from, so vendors and invoices are joined. And then I'm as the on I.vendor ID. I'm looking right here. I'm looking at this join field right here, the two join fields, and wondering if I'm getting them. I want to come to a good solution here, a way to approach this that is, instead of just slashing at it, I want to come up with something that's a reason for what I'm going to try. What would you try? I think we've got kind of the right idea going here, but I'm not sure that that join is right where, because I've got a vendor ID in all three of these tables. And I'm wondering if I shouldn't be looking at the v.vendor ID, the vendor's ID. I'm wondering if that might not be more appropriate. I'm going to give that a try. And back to 113 rows. That didn't work. Ideas. When I execute this, the minimum date I'm pointing up here, I keep wanting to get up and point to the screen. I need to stay with the, okay, here are, let's see if I shift click it, okay. There are 3 for Mallory lithographic, for example. And I want Mallory lithographic if I return the invoice number, I'm going to have 3 invoices. I'm not grouping, I can't group by invoice number. So if I I'm not sure that this one isn't better. Yes, ma'am. Okay, just a minute. Let me put this on the. Let me put your thoughts on the recording I'm making, Donna. Go ahead. You're saying that we need one more one more statement.
Where statement. So if we have a where statement before the order by, then we just have one rule for each vendor. So where invoice date equals to my early date or my date.
I think you have the correct solution, Donna. Did you guys hear what she said? And I believe you have the correct solution. Okay, where the invoice date, because notice that the invoice date, my min date, I'm curious why I'm not seeing it in the output as my min date. I'm seeing it as invoice date. That's causing me some concern. So I'm selecting vendor name, invoice number, and the selection up here is my min date, which is coming from this one. Mm-hmm. Yeah. Okay, now I'm saying I must have run something different. Okay, and so Donna is suggesting a where clause here. Invoice date. Question? Okay. For the invoice date, I don't have to say I dot invoice date because I only have one of them. Equals my min date. And there we have it. Thank you, Donna. I'll get that added to the solutions. Now you guys can, anybody who watches the video will get to see the solution. I believe that is the solution to number 7. Is that 7? That's 8. Okay. Number 7 we did. Number 7 was actually easy compared to 8. I think this one could also have been done in a correlated subquery, but I like to avoid those. If I can, they can. So the subquery is giving us the vendor ID and the minimum, but we need the vendor name. So the subquery there is just working from invoices, and grouping by the vendor ID, it is finding the minimum invoice date by that. So when I'm working trying to debug the subqueries, I will almost always, anytime I can. Now, if I'm in a correlated subquery, I can't do this, but I'll try to run this guy by himself. And notice that I'm seeing the vendor ID, so I see 34 rows. And down here, vendor ID number 999 in that is a bogus vendor ID that I put in there. So when I throw in a bogus one like that and I say, you know, I believe we found that one on one of our outer join assignments. So that's a vendor ID that's in the invoices table that does not match any vendors. So in theory, it shouldn't be there, but I put it there. So that's why I'm getting 34 rows here. I'm getting one vendor ID each. So I'm getting the vendor. And then the where clause is I think I could also put this in the where clause. I could also put this in the join, I believe. I'm going to give that a try. Let me get a copy on it since I've got one good solution. Here's another solution on vendor ID and I believe that this will also be a solution. In general, the on clause of a join really is a where. So both of these are solutions. Since this is part of the join condition, you could have it up there in the on clause, or you could write it as the where clause. It is inappropriate usually to put something in the on clause that doesn't have anything to do with the join. But in this particular case, because the invoice date equals my minimum date, like this. This is a recording. This will be available on the recording. I see some of you taking pictures of it, and that's fine. You may take pictures, but this is a solution, and this is another solution. I'll put here number 1. Solution 1. Thank you, Donna, for noticing that. And one little tweak there, one little piece that had to link them together. And what was bugging me when I was going through that, and I was trying to do it, was that I was getting the duplicate dates. So I want to see 33 rows in the output. Couple of things I wanted to mention with respect to as we go on. Let's see, what have we got left in this class? I'm going to pull up the let's see, today, the Friday, so we have go ahead to November 1, 2, 3. We have 3 meetings in November. Let's see, 24th being Thanksgiving, so we won't meet then. And then I believe we will have one more meeting in December on December 1st. So it looks like we have 4 more class meetings. Okay. What I will probably do is I will, at some point towards end of November before Thanksgiving, we will have a test 2. And then since we're running out of time, I will make the final be essentially a makeup. Okay. So if you did well on both test 1 and test 2, you will not be required to take the final. Looks like we have 4 more class meetings. Some things, the database that we are using for the class should be named AP underscore DB. I said that in about the first class meeting. So if you would please have that as the first line of your code, this causes it to run on my machine. Now, if yours is named something different, oh, well, you can name it something different, or you can create a database named AP underscore DB. Okay. And then run your create AP in that environment, and it will be there. If yours is named just AP, so you have use AP, I don't have one named AP. So when I hit that use AP, what I do is to grade your code, I will download it first. I download your file, pull it over into SQL Server, and then I execute it. Say execute. And I'm looking for it, first of all, to run with no errors, which is always nice when it does that. And then I look at the number of rows returned. For example, I do my solution, and then I count how many rows I get. I won't always have exactly the same number of rows as you do. Sometimes people will change their data. So if yours is getting a little bit different rows, but when I run yours against mine, I should get the same number of rows. There may be some interpretation differences that cause one more row to pop up or something. In that case, I have to go through and look at yours. If there's a huge difference, then I have to go through and look at each query. So, for example, when I get this one down to the final solution I want to have, I want to run it, and I get a row count at the end. So it runs all 8 queries, and it tells me how many rows it returned total. If you return that many rows total, that's about as far as I'm going to look. Okay, but I am looking for if I don't have use AP underscore DB, if you have your database in there, it's going to hiccup right there, and I'm going to have to stop and go fix it. It's not the end of the world. I can fix it. I just go type that line in, but it means that you don't have the right database. Other thing that I'm going to become more of a bug about is this term right here, inner join. Okay. Those of you, for anyone listening, I'm going to start taking off if you don't say inner join and outer join. I've been sending messages on that, say, always write inner join, outer join. If I see join without the word inner or outer before it, I'm going to take off, even though you can get away with that. So you can just say invoices join vendors, and you get an inner join. Okay, I'm looking for the word inner and outer, at least with respect to this class. Later, you can also drop the word as, so you could just say invoices I join vendors V. Questions on any of the rest of them? Time is it? Yes, ma'am. Jocelyn. Okay, go. Number 6. Let's go read the question. Number 6. Write a select statement that returns a table. Well, all select statements return a table containing a single column with one value per row, representing the average of the largest unpaid invoice submitted by each vendor. Single column with one value per row? No, wait, that should be two values per row. Oh. So, okay, one value per row. Okay, first of all, can we get this? The vendor ID and their largest unpaid invoice. Donna, this one might be just about like that last one. Right to select say, so first I want to get this. Can I get the vendor ID and the largest unpaid invoice? Okay. Let's see if I've got it here. Does this do it? Select vendor ID, max invoice total, the max as my max from invoices, where the payment due is greater than 0. Pausing here for questions. Jocelyn, does that make sense? That just a subquery. It is pretty straightforward group by. So this says, give me the where clause. Gives me the unpaid the invoices that have a balance due. Vendor ID. So if I execute just this subquery, and I like doing that, I get a total of 8 rows. And I believe that's what I have there. Now, I'm going to go in there. I'm just going to go in there and take out the maximum out of it using the taking it as a derived subquery. The only thing that the outer query is doing is stripping out the vendor ID. Yes, ma'am. I don't believe it will. I believe that I'm curious if lots of them won't let you do this, but I am a little bit curious. Will this work? If all I did was have just suppose I took out vendor ID. And I'm thinking this might work in SQL Server. And it does. Okay. So it kind of surprised me there. But I really wanted to do a derived subquery on this one was my objective. But this one I can do because SQL Server will allow me to group by vendor ID and not select vendor ID. Okay. Some platforms will say you have to select it. So this worked, this had to be a derived query in Oracle, but it doesn't in SQL Server. So I'd like to see a derived query on it just for giggles. But if you can write this one as just a plain old select from where. So, other questions? Okay. I'm going to skip over Module 9. We have done Module 9 where we have inserted rows and deleted rows. And I'm going to move ahead to Module 10. So I'm going to skip over Module 9. Basically, we've done that. Here's a pretty good video there on the first page, Understanding the Data Types in SQL Server. Each SQL platform's data types are slightly different, enough so that this is a big difference in SQL. When you have a data type and a date, when they're not quite the same, this means that a date in Oracle and a date in SQL Server are different creatures. When you say a date in Oracle, it is a date and a time. If you say date in SQL Server, it just has a day, just a day of the year. So if you say date, it's only a date. If you say date time, then it has a time with it. So there in SQL Server, we have a date, we have a time, and we have a date time. Okay, they are slightly different. Data types fall into 4 basic categories: string or character data, numeric data, numbers, dates, times, or both, and finally what we call the binary objects, large binary objects, blobs, binary object. And so this can be, you can put a video in your database if you give it the right type, if you give it a binary type. Large binary objects, I can put in a picture, I can put in a digitized fingerprint, I can put in your signature. Okay. And this is frequently done, but this isn't very exciting to us as database. We don't really care a lot because anything that we put into a database that's like that binary, it could be executable code. Sometimes that gets interesting. But if I have your picture in the database, I have no way to search for your picture other than using your name or your student ID. There's no way I can take your picture and say, database, go find me who this picture belongs to. Can that be done through facial recognition? Yes, but it's a whole nother program. Move on through this. Okay. Essentially, an integer is simply a binary number, just a number stored in base 2. How many bits or bytes doesn't, well, but how many bytes it takes up? I take the number of bits that in those bytes. There's 8 bits per byte, of course. And that to the power of 2, for example, an integer is comprised of 4 bytes. That's 32 bits. So that means that that number can contain 2 to the 32nd power different numbers. And that's roughly 4 billion different numbers. So if an integer is signed, meaning it can be positive or negative, I can go up to about 2 billion, a little bit more than 2 billion. I have the actual numbers there. 2,147,483,647 and 48. Now notice that there is always one more negative number than positive number. Why is that? Because of 0. Okay. Small int is 2 bytes and tiny int is simply 1 byte. With tiny int, we do not have positive and negative because then we would only get up to 127. So we can go from 0 to 255, and you're responsible for knowing is that positive or negative. Many of them do not give you a tiny int because handling 1 byte is just too much trouble. Many databases will not give you anything smaller than an int. So if you have a number, an integer number, it's going to take up 4 bytes. In today's world, 4 bytes is trivial. 4 bytes is like a penny laying on the ground. What would we gain by having a half-penny coin? It would be more trouble to fool with the coin than it would be to have it. And that's kind of where we're going to. The databases are moving away from the small int and tiny int, as these are just too much trouble. And so most of the time you have an int, an integer. Now, all integers suffer from, have I mentioned this before? I believe I mentioned it on day 1. Integers suffer from overflow. So anytime you have an integer, you're going to have the problem of overflow. If it gets too big, if I get above this 2 billion mark by very far, I'm risking the idea that this number will roll over into, and when it rolls over into the negative. This is because of the way we keep numbers in our system. Have you guys okay down there? Doing okay? So an integer, if I have overflow, the question is always what happens in the system? What happens if I try to put a value into an integer that is too big for an integer? What does it do? And well, let's see if I can do this. I usually do this on the board. All integers will eventually overflow. Years ago, automotive speedometers overflowed at 99,999 miles. Do they do that anymore? Okay. Now they're digital devices, so we just add bits to them. The old days, because we had 5 digits, we could represent 5 digits, and then when it finally hit that 99,999 miles, everybody had a big party. They stopped and ran around the car, laid hands on the car or something. And then, we're at 100,000 miles. The speedometer rolled over to 0. All integers will do that. There is a limit to how much memory you have assigned to an integer. In the case of an integer, it is 4 bytes. 4 bytes is roughly 4 billion, but because we have positive and negative, we can only go up to about 2 billion. If we overflow a positive and negative number, here's my favorite joke. This is a trick question. What state in the United States is farthest east? Trick question. Maine would be one option. I always get in trouble every time I go up to, my wife is from Newfoundland, which claims to be the farthest east. And I point out that Alaska, the Aleutian Islands, extend into the eastern hemisphere. Thus, if you go far enough west, you end up east. There's several islands out there at the end of the chain that have a east longitude. And I told you it was a trick question. Obviously, you mean by going east, but if I go far enough west, I end up east. If you get bigger and bigger and bigger, ultimately, when you overflow, you will overflow into the largest negative number. And this is because of the coding, the way we code these numbers. If you ever hear of the word 2's complement, that's how an integer is represented. There is no positive and negative sign with it. It's just if you, the way that we represent the numbers, when you go backwards in the negatives, it's like going backwards in your speedometer. If you start at 0 and you go backwards and your speedometer runs backwards, the first number you should see is 99999. And that would represent -1. And then it would be 99998 and so on. That's -2. And they would come together when the at 49999 is the biggest positive number you could represent. When it rolled over to 550000, that is the biggest negative number. And this is very easy to handle in the binary. So this is how we represent numbers. If I had to put a positive and negative sign with it, then I would have positive and -0. And that would really give me a lot of trouble, and because then I would have two numbers that were the same thing. To a computer scientist, 0 groups in with the positive numbers. It has a positive sign, even though it's not positive, but it's not negative, so we group it with the positives. Okay. All integers overflow. Anything with a fixed decimal is an integer. If I fix the decimal, I've got an integer. Okay. If I tell you that this number always has 3 decimal places, I will never store 3 decimal places. It will always just be stored as an integer. And then when I show it to you, when I use it in a calculation, I will just shift the decimal. I will just divide by 1,000. So I'm always going to work in decimal places. Thus, if I create a number like this, and I say that that number is a decimal, 8,3, I'm saying that that number is large enough to accommodate 8 digits. 3 of these are always to the right of the decimal. We have a fixed decimal point, therefore it's a decimal. Now, we know that we work in base 10. So the question is, if I have 8 digits, that means that I can have 10 to the 8th power, or 100 million. Right? It doesn't look right. 10 to the 8th power, 6, 7, 8. Okay, I got 8 zeros. 100,000, 100 million different numbers, 10 to the 8th power. Now, I'm going to take a log base 2. What does log base 2 mean? 2 to what power is roughly 100 million? And I want the next one up. So I want to know that it will require 27 bits. So log base 2 of 100 million is going to be like 26 and some change. I'm going to have to go up to 27. So in order to, if I have to represent 8 different digits, I'm going to need at least 27 bits. So remember, when you do your algebra stuff, pay particular attention to those logarithms if you're into it. So I'm asking 2 to what power is at least 100 million? And it probably won't be even. I probably won't come out right. So I'm going to get 26 point something, 2 to the 26 point something power. That means I've got to go up because I can't have half of a bit. So I have to have 27 bits. And one more because of the sign. So that's 28 bits. But I can't allocate 28 bits. Okay. So I'm going to go up to 32, and I'm going to give you four bytes for that number. So if you say that you want, so a decimal that contains 8 digits, 3 of which are always to the right of the decimal, what is the largest value I can put in that? I'm going to have 8 digits. 3 will always be to the right. So I've got 5 digits to the left of the decimal point, 3 to the right. The biggest number is going to be 99,999 and 99 thousandths. After that, I'm going to run out of room. What I'm going to find out is, I think that if I say a decimal 9,3 is probably also going to take up 4 bits because I have to allocate it on bytes. Money is always 8 bytes. Money is an integer. Money always fixes the decimal place at 4 decimals. There's always, if you say it's money, it contains 4 decimal points. Always 4. Therefore, if you say it's money, you've got an integer. Okay. Well, it is and it isn't. The question is it the same thing as an integer in mathematics? An integer in mathematics has no upper bound. In a computer, everything has an upper bound. Okay. So there are a X number of bytes allocated to this integer. We're out of time. And therefore, when I run out of that, I have hit overflow. I have hit my upper bound. Now, what does the system do with that? That varies from one system to the other. Some will give you an error. Some will overflow to a negative number. I suspect most of them give you an error. I'm going to set it up and test it. I'll tell you what happens. But if I get too big for an integer, all I can do is go to a large int. So I have to know about how big will this integer get. And if I'm over 2 billion by much, so I've got a number here that's going to go over 2 billion. I probably need to go to a larger value, one that takes more memory. So if I go to a large int, sometimes they call them big int, and that allocates 8 bytes. Now I can go up to 2 to the 63rd power, and I don't even know what that number's name is. It's so big. Questions? Okay. Let's see. We are about at break time, and there's one thing I want to cover in a little bit more detail than this. This stuff about the integers. Whenever you declare an integer or not an integer, but a number, and you say it has 8 digits, 3 of which are always decimals. Even if you don't put them there, it's going to be 0.000. Okay. So that means I can have 5 digits to the left of the decimal point, up to 3 digits to the right of the decimal point. Maybe it will take a little bit more than that, but that's all you're guaranteed. Okay? You have an integer because you fixed the decimal. We like integers. I make $10.37 an hour. Does that have a decimal point? 10.37. But I will never, ever store it like that. I'm going to store it as I make 1,037 cents per hour. Now it is an integer. As soon as you say you always, always, always put that decimal point there, now I just shift it out and I've got an integer. Once you fix the position and you tell me it has 32 decimal points always, I divide by 10 to the 32nd power, shift that decimal point out, multiply by, and then I divide by when I give it back to you. So I'm just shifting that decimal point around. That comes very easy to me. When I'm talking about a number that I don't know where the decimal point goes, and this is float or real, okay, avoid these anytime you can. Almost never do you need them. You only need them if you are working with something like a circle, for example, arc length, and you got this thing called pi in there. That's a floating point. I don't know where the decimal point is going to be in this thing. Now I've got some problems. Okay. Usually what I will do is I will arrive at some number for pi. I know what it is, and now I have a fixed decimal. Anytime I can fix the decimal, I'm going to. We're going to avoid float and real in our tables. Okay, it is break time. A little bit past. I'm going to pause the recording. And I am now resuming recording. I'm going to put this esoteric discussion to rest here pretty soon. We've been talking about integers. Let's talk about the other end of this thing, which is the floating point or the real. Anytime I am dealing in floating points, I'm going to have an error. We like integers because integers are always exact. Now, I have the problem with an integer of overflow. If I get too big, I just run out of room. But that is an obvious problem. Anytime I'm working with a floating point number where I don't know where the number is, where that decimal point is, I have no way of knowing, I will always have a little error in that. For example, consider 1/3. 1/3 as a decimal is 0.0.333333333. And at some place, finally, I get tired of saying 333, and I have to stop. When I stop, I have introduced a very tiny little error into that number. And this is just going to happen. We think this is, it will happen where you don't believe it will happen. For example, think of a number like 0.2, 20 cents. And we represent it as a decimal, a floating point decimal, not 2 cents, not 20 cents, but 0.2. And the question is, does that ever terminate? And you say, of course it terminates. 0.2. And what is that? That is 2 20/100ths reduces to 2/10. Okay. Now think about 10. Think about base 10. The denominator is 10, and 10 is 2 times 5. In base 10, that will terminate just fine. In base 2, it will not. How do I tell if a decimal, if a fraction, will terminate as a decimal or not? For example, 1/2, 0.5. Does it terminate? Of course it does. 1/3 does not. 1/4, it does. 1/5, it does. 1/6 does not terminate. Why not? There's a rule. 1/7, no. 1/8, yes. 1/9, no. 1/10, yes. 11, no. 12, no. 13, 14, 15, no. 16, yes. What is the rule? The answer is, look at the denominator. Consider the factors of the denominator. Okay. Let's go back to 6. What are the factors, the prime factors of 6? 2 and 3. We're in base 10. What are the prime factors of 10? 2 and 5. If there is anything in the denominator, prime factor, that is not in the base, it will not terminate. This is why 3 will not, 4 will. 2 times 2, we have 2. 5, we have a 5. We're fine. 1/25 will terminate. Now consider 0.2, 2/10. 10 is, well, 10 is 10. It'll terminate just fine, 2/10. But if we go to base 2, when we shift to base 2, the only thing that can terminate are powers of 2. If the denominator is not a power of 2, it will not terminate. So example, for something like 2/10 will never terminate in base 2. 1/2 will in base 2. 1/4 will. 1/8, 1/16, 1/32, 1/64 will all terminate. But it will not if it has a factor of 5 in it. Even though it terminates just fine in base 10, when you shift over to base 2, you now have an infinitely repeating decimal. Okay? And that's only a problem when you have to chop it off someplace. And as chop it off you must. This is why we want to stay in integers every time we can. Okay? This is called underflow. When an integer gets too big, that's overflow. When it gets too small, that's underflow. Okay, that's about all I'm going to say about that. I'm going to shift over to my slides. Chapter 8 slides are available to you, how to work with data types. This is where we're going to be next. This is Module 10. It gives us some objectives. I'm not going to read them to you. We've already talked about string, numeric, temporal, and other being the binary large objects. Don't worry about that slide. Integer data types, we have a big int, 8 bytes. Okay, a big int is really pretty big. 8 bytes, it's not just twice, it's twice as big as an integer, but it can hold about 4 billion times more numbers, not just add another 4 billion, multiply it by 2, 32 more times. A little bit like the kernel of rice on the checkerboard, 2 kernels on the first one, 4, and so on. When you get to 2 to the 64th power, you have more rice than there ever has been in the world. I'm going to keep moving here. 8 bytes for big int, so there are our integers. SQL Server gives you a bit data type. There probably is no such thing as a bit anymore. Used to be you could store just a straight 0 or 1, but now it's a byte. SQL Server does not have a data type that we call Boolean. Does that word mean anything to you, Donna? Boolean? Boolean is a value that is either true or false. Okay? X is equal to 3. It's either is or it isn't. It's either yes or no, 0 or 1. We do not have anything that is true or false. And if you want to do that, you have to go with a small integer and make it be 0 or not 0. If you need to store just a true or false value. We don't have just true or false. The decimal data types, and I pointed out that a decimal data type, anytime you fix the decimal point, you have an integer. Okay, these two are something we want to stay away from at all cost, the type float and the type real. Go ahead. Go back to the last slide. Okay, this is called a decimal data type. However, it is a fixed point decimal. Yes, the part in the bracket is optional, and if you just say decimal, I think you get the largest one it can give you. I never do that. I always state both of them. So if I want 0 decimals, I always say comma 0. I always give it 2 numbers. I'm not sure what happens if you just say decimal and do not give it a number. But yes, the part in the bracket is optional. P is what we call the precision. So that would be like decimal 8, comma 3. The P says you have a total of 8 digits. Of these, 3 of them are to the left, to the right of the decimal place. If you say decimal 8, that gives you an 8-digit integer. You are guaranteed that you can store up to 99998 whatever that is. And you're guaranteed that you can do that. You can probably go a little bit larger than that because it always allocates in powers of 2 and on the byte boundary, but that's all you're guaranteed. So if you just say decimal 8, you are guaranteed that you have enough space there to put 8 digits in there, and they will all be to the left of the decimal point. If you say 8, comma 3, you still get 8 digits of precision. That's how big it is. But 3 of them are always assumed to be to the right of the decimal point. Therefore, it's just going to shift them out, and you get an integer. Okay. This one, float and real, those are your floating point. I believe the term real has been depreciated, meaning that it is not used anymore. We like to not use float. Do not use float if there is any way around it. And there usually is a way around it. String data types. There are 2 types of characters. What is the difference? So we have char and varchar. I'm going to take the top 2 first. What is the difference between char data type and varchar? Char is a fixed length. Okay. It always takes up, char 8 always takes up 8 bytes, 8 characters. Varchar, with an upper bound, can change. It can get larger and smaller. There are some benefits and some costs to either one. If I declare something as char, I do not have to worry about it growing and shrinking. Things that grow and shrink give us trouble. They cost more at runtime. I have to allocate the largest thing I can. If I just have 8 characters in there, I am not going to fool with a varchar. Okay. Now, I know our textbook has a name. The name has, I don't know, 32 characters in it, and they make it a varchar. If I've only got 32 characters, I'm never going to fool with varchar. I don't save enough by putting your name in a variable length field to make the system let it grow and shrink. Okay. So anytime anytime I have a person's name, how many letters are in a person's name? Let's just say first name, English. How many letters? 8, that's probably too small. 16? 24? Let's say 24. I'm just going to make it 24 char, and I'm just going to accept the fact that I'm going to make some of them too big. That's okay. Versus if I make it a varchar 24, now I can squeeze it down, and if I only use 7, it drops down to 7. But the cost of doing that is great. So char is cheaper if you can use it. And if you're only going to waste 5 or 6 characters, just don't worry about it. Okay? Questions? Many of systems are going to nchar. What is nchar? Miss Yang. Donna, you know about nchar. National char, international char characters. Okay? It came as a big shock to some of us that not everyone in the world speaks English. And that there are other alphabets besides the English alphabet. So this came as a big shock to people in this country. Other people had known about it all along. But so what we did instead, we moved to nchar. Nchar uses a 2 byte. Now, using 2 bytes instead of 1 byte, well, 1 byte, what is that, 8 bits? That gives me 2 to the 8th power different numbers from 0 through 255. Now, when I talk about 2 bytes, that gives me 2 to the 16th different numbers, and that is approximately 64,000 different characters. Actually, it's a little more than that. I'm calling 2 to the 10th 1,000, and then times 2 to the 6th. So about 64,000. 2 to the 6th would be 64. And if 2 to the 10th is 1,000, it's a little bit larger. Okay. So with 64,000, I can put the whole, all of the different national alphabets in there and still have some room for everything else. So nchar is, if you are only going to store English characters, then char is fine. If your database is ever going to need to put other characters in there besides our English ASCII code, American Standard Code for Information Interchange, anything else ever, go with nchar. It costs more, but you really don't want to have to change it. Talked about that. Dates and times. After 2008, and we're getting a long ways past 2008 now, if you just store a date, it takes up 3 bytes. If you store a time, it takes up to 3 to 5 bytes. Date time is a typical one that we will typically make it date time instead of just date, because that allows you to store a date and a time. If you don't give it a time, the time defaults to 0. Note that that is date time 2. What happens sometimes is the older people, when they had date time back in prior to 2008, it was stored in a different way. Then they changed the way that it was stored, but if they changed it, it was incompatible. So date time and date time 2 are incompatible, but the modern way to say a date time in SQL Server is to say date time 2. Okay? This is because they took a blind alley once upon a time, and they released something that wasn't quite ready. Oracle did the same thing. Oracle has type char and type varchar, but because they made a mistake also, if you're in Oracle, it's not varchar, it's called varchar 2. You'll see that done frequently. So that's how it says, well, okay, we can't call it date time because it would be incompatible with something older. So we're calling our new one date time 2. Okay. So that's just something that you'll remember for SQL Server. It's got a 2 on the end of it, date time 2. If you go over to Oracle, it's just date time. If you're in SQL Server, it's varchar. If you go over to Oracle, it's varchar 2. That gives you a precision for it. How, okay, a date, back in the day, we stored our dates in the form of characters. We stored it as a day, a month, and a year. So today, what's today? The 26th, 27th? So 271017 would be today. Okay. And what was our problem? In the year 2000, you guys are old enough to remember it, I'm sure. Do you remember year 2000? I'm sure you are. Everything was going to, the world was going to end. And everybody was running out and buying ammunition and stockpiling food. And, well, the world didn't end. What we had to do, we had to reformat everything. So what we did, we went back in time and we got a time and we said, this is 0. So 0 is Happy New Year 1970, by the way. And so a date and a time starts at 0. If you say 0 is stroke of midnight 1970, New Year, and it is a number, so 0 is that time, and then the date and the time is the number of clock ticks that have happened since then. Okay, so the N tells you how fast does your clock tick. Okay, I've got a clock that ticks really, really fast. Tick, 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 tick. Okay, I can tell you a time with greater precision. A time is an integer, okay? Just the number of ticks. My clock ticks once every millisecond. That means that I can tell you very precisely what time it is. I've got a clock that only ticks once every second. I can't tell you half seconds. I can only tell you, is it 30 seconds or 31? I don't have anything in between. I've got a clock that only ticks once a year. I can tell you it's 2017. When my clock ticks again, it's going to be 2018, but I can't tell you anything in between. So the clock clearly that's ticking the fastest is going to have the biggest number. And that's what that N gives us, is a precision. If you just say date time, I believe you get 1 tick every 3 milliseconds. I'm not sure on that. You may just say date time. I'm going to talk more about date formats later. There's something else I wanted to get to. Okay, data types. Highest level down to the lowest level. When we change from one thing to the other, when I change from a char to a varchar, I can usually change going up that. So if I'm going up this in order of precedence, if I'm going from a char up to a varchar, it will usually be fine. It will usually accept it. But I typically cannot put a varchar into a char variable, and so on. Let me get to where I wanted to go here. Okay, here's what I wanted to do. This is, now we're back into SQL programming. Always a computer programming language. Any computer programming language will give you a way to change from one data type to the other and say, I don't want it to be a date. I want you to change that into a varchar string. Now, what is a date? A date is an integer. When it shows it to you, though, it shows it to you as a date because that's probably what you want to see. I have a way of changing from one to the other. and that is with the cast function. Okay. So I am on slide, so I'm going to start talking about the slides now. I am on slide, what slide? Slide 19. And this is what we're going to do in the exercises, essentially. We're going to cast dates and stuff back and forth. Okay. Select invoice date, invoice total, and cast. So this is a selection, this piece right here. Let's see if I can. Oh, editing. Okay, I'm going to copy this. If you enable editing, it will let you copy from PowerPoint. So I'm going to copy from PowerPoint and drop it over into my query. Okay, cast invoice date as varchar. Okay, so there it is, and the as at the end of it is just a name for the select. Now, what am I going to get? I really should have set a size on this. So I should have said varchar 20 or something like that. I should have given it upper bound. But if I cast the invoice date, now what will I get? I will have the date. If I had today's date, it would give you today's date as characters. Okay. No. Yeah. I think that's going to work there. I believe that should work. Let me execute this. So the varchar date, invoice date is a date time. Therefore, it has a date with it and a time. But when we put it in there, we didn't put in a time. So what happened? It just defaulted to 12 p.m. If we're going to default all of them, or 12 a.m., I guess, if we're going to default all of them, we might as well go back and make it a date on our, if all we care about is it a day, is the day that it was done, then all we need is just date. But that's date time. Lots of times when I am working with it, what I will do is I will timestamp it. In other words, when I insert something in that, I will insert the current tick of the clock. And in that case, I need a date time. I will use that a lot as a primary key, the time. I don't like counters that go 1, 2, 3, but if I grab the clock and put that in as the primary key, as long as two of them don't happen at exactly the same time, and they probably won't ever, then I'm going to have a unique value there. And nice thing is now I keep them sorted by time. Okay. Invoice date, let's see, varchar date. If I were to look at this, notice that this date is characters. You're seeing the default, the invoice date, what is showing you there is the default format. You can change that. I will show you how to do that. You can change the way you see it. So if I change the way I want to see the times, and I'll show you how to do that, I won't see it in terms of what am I seeing there. It shows me year first, month, day, followed by hours, minutes, seconds. Okay. If I change the format of the way I want to see it, then that will change, but the varchar date won't, because I put it in there as characters. Now, this is only important in that the cast function is what's letting me do that. Questions? Casting. Matthew, what do you see? What do you call when you cast one variable as another? I'm looking for a typecasting. Well, I know that, but we don't have that in here. We're just casting, so that's a static cast. If it can't do it, this one will barf. Yeah, it's static. I'm saying make invoice date be a varchar. Now, back in the past, it was a time, and we know that the time is stored as an integer, but I want you to take it and change it into a varchar. Just for this one. Don't change the type, but for right now, while it's showing me, so as varchar date is going to just be a string of characters. Take invoice total, cast it to an int. When you cast something that has a decimal, if it has a decimal, even a fixed decimal, if you cast it to a decimal, what happens to the decimal places? Chop. That is typically true in programming. Most of the time, if you, it's not always true. If I push an integer in, if I take something that's got a decimal and make it say, oh, make it fit into an integer, there's two choices. It could round, it could chop. Most of the time, it will chop. I can show you examples where it'll round, but unless you specifically say round. And finally, cast invoice total as varchar. I'm saying that's no longer a number. It is now the character. The first one is, let's look at the first one. Varchar date is not a date. It is the character M-A-Y space 1, 5, and so on. Integer total is an integer. It has chopped off the decimal. And varchar total is the character 3, followed by the character 8, the character 1, the character 3, and the character 3. Are you with me? I'm losing my microphone here. Questions? Cast works the same way in all programming languages, all databases. And its syntax is cast, open parentheses, field name, as, and in this case, I don't believe the as is optional. Cast invoice date as varchar. It looks different in other programming languages besides SQL, but it always has this option. I say it is better to specify the digits. I don't know what happens if you don't. I always do. It might allocate just the size, since I'm not putting it into a database. I'm not creating a table. My guess is what it does, it just figures out what's the best size and gives you that. Now, well, here, there is a way that I can put this into a table straight from the select, and we're going to see that. Okay. This microphone is just about to drive me nuts. Let me get situated here. Okay, I'm going to have to fix my microphone. Yeah, please. I'm all tied up here. Thank you. Mm. Back on. Cast. Now the thing about cast is if it is impossible to do, it will error out. So if I give it something that it cannot do, I don't know whether I can cast a date as an int or not. Um, um, let's try it. Cast. Let's see what happens. Cast invoice date as int. I'm expecting it to error, but maybe it won't. Okay. It gave it to me as an integer. What is that? That is the number of clock ticks, number of days that have happened, number of times that that clock has ticked since time 0. Let me give it something. So that's what I thought it might do. Let me. I'm going to try to cast it into one character and see. In other words, I'm trying to give it something that it's impossible for it to do. So I don't think that first one is possible. Well, it is. It gave me an M. um, what would happen if I tried to cast it as money? Now I'm going to try to cast the date as money. And it's casting it as money. I'm trying to get something that it can't do. Okay, let me go the other way. Let me cast the invoice total as date. Bingo. Can't cast money as date. I can cast a date into money. Why is that so? Because underneath date is an integer, but it's not gonna, it goes back to this thing. Let me go back. Where is it here? Notice the highest to the lowest. I can usually cast up, and since the date time is the highest, everything that I was trying to cast, it said, yeah, I'll go ahead and cast that because that's going up in the precedent. But when I tried to cast in the other direction, I took a date. And so if I take date and try to cast it as money, or date and try to cast it as char, it works. But if I take something that's money and try to go up to a date, it does not work, and it errored out. Cast. Convert. Now, the difference between cast and convert is that you are allowed to do a lot of formatting here. The book is really a better source on this than the slides. So I strongly suggest that for convert, you take a look at it. Convert to varchar. So notice that convert is different from cast. Convert is unique to SQL Server. So it won't work anyplace else. That's why I don't cover it a whole lot. So we're going to convert to varchar invoice date as varchar date. And let me run these in the copy. Paste them there. Notice that if I just convert varchar, so I convert it to varchar, I get this. Okay, varchar date, I get May 15th, 2017, 12 a.m. That's the default. That's the way you see it if you don't specify. I have the ability with convert to give it a format, and the formats are listed in the book. I usually have those in front of me. Let me find the page number for you. So when we're talking about a convert, look it up. Convert. Page 254, I believe. Okay. Your style codes are listed on page 255, and that's where it got a lot of this stuff from. For the you see a lot of the stuff reproduced from the slides, so they came from page 255 of the textbook. Common codes for converting date time data to character data. For example, if I use a 1 or a 101 here, it looks like this. It's just 5, 15, 17. It did not change the way it's represented. It's still represented in all of its glory, but it's only going to show it to me. If I say convert, it only shows it to me as 5, 15, 17. And likewise, if I give it a 107, I'm going to see it as month, day, year. So there's 107. If I say convert invoice total, and if I give it I can give it a format. So the difference between cast and convert is that convert is unique to SQL Server, and it allows you to give it a formatting option. Common codes for converting numbers. So when I say invoice total 1, I'm using 8 digits. So invoice total 1, I'm not sure exactly what that does. I'm going to let you read that. One I wanted to get to, and we'll end with this one as it is 12 o'clock, is on page 257. It gives you the try convert, and this is, again, this is unique to SQL Server. Let me bring it up. Try convert. The thing I like about try convert is essentially it gives you convert, again, like cast. So cast is the standard SQL. Standard is the way it's done in SQL. Convert is unique to SQL Server. I don't really care. Convert gives you the ability to format it more than than SQL does. But the thing I really like about it is try convert. If I give it try convert, that's convert. Let me get try convert up here. There we go. Try convert. What happens if I try to convert something, if I have a string that is something like May, if I put May 32nd, 2017, or February 30th. There is no February 30th. Okay, that will be an invalid date. If I try to convert a string to a date and it's an invalid date, what's going to happen? If I try to cast it or convert it, I'm going to error out. Okay. Now, try convert is nice. Okay, here it is right here, the last one. Try to convert the date February 29th, 2011 as, try to convert to date. Now, I'm going to try this first on the other one. So let's go back there. This is convert. Try convert to a date. February 29th. As barf. That means it's going to die. Okay. And as soon as it hits this, no, this is just convert. Okay. So this is what happens with convert when I execute. Boom. Where was it? Was it there? So that's fine. Now, as soon as I take this and try to convert this one, I think I had the error in the one above it. I'm going to fail because I failed when converting date time. So it died. Okay. Now, if I change it from convert, instead of convert, I'm going to change it to a try convert. This is why I like try convert. Now, when I run it, instead of everything coming to a screeching halt, I will just get a null. Okay, so that's the beauty of try convert. So convert is like cast, but it gives me a little bit, I have a few more options. Now notice that they are not exactly the same. Convert and cast, the way that they're set up. So one of them says cast some field, the word as the data type, and then you give it a name usually. Convert says convert to the type, comma, the field name. So they are different in the way that they're set up. And either one, cast or convert, if it cannot do it, it dies. Try convert says try to convert it. If you can't do it, just set it null. Okay. So try convert is the one I really want. Try convert does everything that convert does, but it puts that safety net in there. So I will almost always use try convert instead of convert. Otherwise, I'm going to be over in the cast. Questions? The exercises for Module 10 are fairly easy. You should be able to knock those out quickly. Basically, they're just asking you to convert, and try convert, and cast. That's it. Okay. Questions? Okay, I'm going to wrap up the recording. Ending the recording.